Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LJIT. Earlier lecture, we are already discussed about the power series and absolute and conditional convergence of this series. Today's session, we are going to discuss about the ROC, radius of convergence, and IOC, interval of convergence. Let's start with radius of convergence and interval of convergence. Firstly, summation n equal to 0 to infinite an x minus a raised to n be a form of power series. Then here un equal to an x minus a raised to n, that means n plus 1 term of the series, that is un plus 1 equal to an plus 1 x minus a raised to n plus 1. Now applying the root test as well as ratio test. Here I am taken the ratio test, limit n tends to infinite, mod of un plus 1 upon un. You can take the ratio un upon un plus 1 as well as un plus 1 upon un as you like. Here I am taken ratio in form of mod of un plus 1 upon un, substituting the values of un plus 1 and un and give the simplification, then it becomes modulus an plus 1 upon an into x minus a. Here x, which is in terms of variable form, means we don't know value of x which is positive or negative, then x minus a, which is common, that is our constant term in terms of mode, then applying the limit n tends to infinite, mod of an plus n upon an. Now solving that term, then we get any finite value, that is indicated by L, then it becomes mod of x minus a into L. Now let's see the condition of the ratio test. For mod of x minus a into L, which is less than 1, that means simplified that term, then mod of x minus a, which is less than 1 upon L. That particular range given series is convergent. And for the mod of x minus a into L, which is greater than 1, simplified that term, that means mod of x minus a, which is greater than 1 upon L, at that particular range given power series is divergence. And for equal to 1 upon L, we cannot say about the given series is convergence or divergence. That means ratio test is failed. Then we have to apply another test. Here 1 upon L, which is indicated by the radius of convergence, then which is written in form of 1 upon L equal to R. Now let's see the for a given power series, summation n equal to 0 to infinite an x minus a raised to n, there are basically three possibilities. That means for the all the values of x, our given series is convergent, then we can say that our radius of convergence, which is infinite. Secondly, suppose for particular one point, means at center at power series, means for x equal to a, we can say that given series is convergent, then our radius of convergence, which is 0. Now if the r is any non-zero positive real number, that means mod of x minus a less than r is convergent, and mod of x minus a greater than r means at this particular range it is divergent. Then according to the case 3, we have to define interval of convergence. That means mod of x minus a less than r. Now simplified that term, means expanding the modulus. For example, mod x less than 1, then we can write minus 1 less than x less than 1. Same manner, here we can write minus r less than x minus a less than r. Now simplified that term, then we can write a minus r less than x less than a plus r. That is our interval, means that particular interval given series is convergence, then we can say that it is interval of convergence, which is also called the range of convergence. Now here basically for conditions or for possibility to the range of convergence or interval of convergence according to the endpoints, means both the endpoints has a convergence, or we can say that both the endpoints of series which is divergence. Means if both the endpoints are divergent, then we can write open bracket a minus r to a plus r. If both the endpoints are convergent, then we can write close interval a minus r to a plus r. Now, maybe possibility left endpoint is convergent and right endpoint is divergent, then we can write open bracket a minus r to close bracket a plus r. Similarly, we can say that left endpoints which is convergent and right endpoint which is divergent, then we can write close bracket a minus r to the open bracket a plus r. These are the possibility to the interval of convergence. Now let's see the examples of the radius of convergence. Find the examples of the radius of convergence, and we can say that interval of convergence of this series summation n equal to 0 to infinite minus 3 raised to n into x raised to n upon square root of n plus 1. Here un equal to minus 3 raised to n into x raised to n upon square root of n plus 1. Here our question which is in form of constant raised to n, x which is constant, or our question has a variable form, then we can say that in form of power series. Here constant raised to n, then what obvious, we have to apply ratio test. But ratio test which is applicable only for series of positive term. Then here we have minus 3 raised to n, and we don't know exactly what is the value of x. That means x may be positive, x may be negative. Then we have to apply in terms of ratio test in form of modulus. Means we can write limit n tends to infinite mod of un plus 1 upon un. Now substituting the values of un and un plus 1 and give the simplified, then it becomes square root of n plus 1 upon n plus 2 into minus 3x. Here we written in form of modulus, then minus sign which is absorbed and come outside the module, come out the limit, then we can write mod of 3x limit n tends to infinite square root of n plus 1 upon n square root of n plus 2. Now in numerator and denominator portion of the limit term root n which is common and cancel out, then it becomes square root of 1 plus 1 upon n and denominator portion 1 plus 2 upon n. Now n as a infinite applied to the limit, then it becomes mod of 3x. Now according to the conditions of ratio test, given series is convergence, because our limit which is less than 1, then it is convergent, our series greater than 1, that it is divergent. Here we have to taken the ratio in form of mod of un plus 1 upon un. You can take the ratio un upon un plus as you like. If you take the ratio un upon un plus 1, then our limit which is greater than 1, then it is convergent, and our limit which is less than 1, then it is divergent. As you like, whatever the ratio you have to taken. Here I am taken the ratio in form of mod of un plus 1 upon un. Then our limit which is less than 1, then it is convergent, and our limit which is greater than 1, then it is divergent. That means 3 simplified that term, then we can write mod of x less than 1 by 3. Now expanding this term, then we can write minus 1 by 3 less than x less than 1 by 3. At that particular range, our series is convergent, and other than that means mod x greater than 1 by 3, our series is divergent. Means here condition of the convergence which is mod x less than 1 by 3. Hence we can say that radius of convergence which is r equal to 1 by 3. Here minus 1 by 3 to minus 1 by 3 to the 1 by 3, given series is convergent. But what about the endpoints? That means what about the 1 by 3 and minus 1 by 3? Then we have to check out the at the endpoints given series is convergent or not. Firstly, if x equal to minus 1 by 3, then substituting the x as a minus 1 by 3 in un, then un becomes minus 3 raised to n into minus 1 by 3 raised to n, denominator portion square root of n plus 1. Here minus 3 raised to n minus 3 raised to n which is cancel out, then our series becomes 1 upon root n plus 1. Here our series which is in form of polynomial form, or we can say that different power of n in numerator and denominator portion. Then what obviously you know that which test is applicable? Correct, it is comparison test. Then according to the comparison test we have to find the Vn. Then according to the dominant term in numerator portion and denominator portion, then it becomes 1 upon root n. Now, applying the limit n tends to infinite to the un upon vn, substituting the values of un and vn and simplified that term, then it becomes 1 upon square root of 1 plus 1 upon n. Now, n as a infinite, then it becomes 1, which is finite and non-zero. Now, here vn equal to 1 upon root n, obviously that is n raised to 1 half, then value of p, that is 1 half, which is less than 1 or less than or equal to 1, then we can say that given series is divergent according to the p series. Here either both the series convergent or divergent together. That means according to the comparison test, we can say that sigma un is also divergent for x equal to minus 1 by 3. Similarly, we have to check for the x equal to 1 by 3. Then un becomes minus 3 raised to n into 1 by 3 raised to n denominator portion, in denominator portion square root of n plus 1. Here simplified that term, then we get minus 1 raised to n upon square root of n plus 1, means given series is alternating series. That means if given series is alternating series, then obviously we have to apply the Leibniz test. Now, according to the Leibniz test, we have the two conditions. Firstly, mode of un which is greater than mode of un plus 1. Secondly, limit n tends to infinite, mode of un equal to 0. Then we have to check the first condition with the help of difference of two consecutive terms, means mode of u of n minus mode of un plus 1. Substituting this value un and un plus 1. Now, substituting the n equal to 0, 1, 2, 3 and so on. Then for all the n belongs to capital N, we get answer which is greater than 0. That means each term is numerically less than its preceding term. That means our series which is in form of decreasing form. Now, first condition will be satisfied. Now, let's see the second condition. Limit n tends to infinite, 1 upon square root of n plus 1. Then applying the limit n tends to infinite, then 1 upon infinite, that is 0. Then second condition which is also satisfied. Then according to the Leibniz test, we can say that given series is convergent for the x equal to 1 by 3. That means, now summary of the examples. Here given series summation n equal to 0 to infinite minus 3 raised to n into x raised to n upon square root of n plus 1 is convergent for the minus 1 by 3 less than x less than or equal to 1 by 3. That means at position minus 1 by 3 given series is divergent, at position 1 by 3 given series is convergent. Then interval of convergence we can write open bracket minus 1 by 3 to close bracket 1 by 3. Now let's check out the one more example based on ROC and IOC. Here summation n equal 1 to infinite minus 1 raised to n x plus 2 raised to n upon n. Find the radius of convergence and for what values of x does the series is convergence, or we can say that absolutely or conditionally convergence. Here un equal to minus 1 raised to n x plus 2 raised to n by n. Here our n term which is in form of something raised to n, then obviously which test is applicable? Root test, correct. Then here nth root of un, that it becomes minus 1 x plus 2 upon nth root of n. Here root test is applicable only for the series of positive terms. That's why here we have this un which is negative term, or we don't know exactly what is the value of x, maybe positive, maybe negative. Then we have to apply in form of mode, means limit n tends to infinite, mode of u of nth root of un. Then substituting the values of nth root of un, the limit n tends to infinite, mode of minus 1 into x plus 2 divided by nth root of n. Here minus n which is absorbed, then mode of x plus 2 which is comes out the limit n tends to infinite, 1 upon nth root of n. You all are aware about the standard limits which is already discussed in sequence. Then limit n tends to infinite, nth root of 1 upon n, that is 1. Then our limit portion, that is 1. Then mode of x plus 2 into 1, then we can say that mode of x plus 2. Now according to the condition of the root test, given series is convergent for the mode x plus 2 which is less than 1, and given series is divergence for mod x plus 2 greater than 1. Now here condition for the convergence, that is mod x plus 2 less than 1. That means radius of convergence which is 1. Here if mod x plus 1 less than 1, then simplify that term, then it becomes minus 1 less than x plus 2 less than 1. Now simplify that terms, then it is becomes minus 3 less than x less than 1. That means given series is conversion of that particular interval, means minus 3 less than x less than minus 1. But what about the endpoints, means minus 3 and minus 1? Now we have to check the given series is convergence or divergence of the endpoints. Firstly, we have to check for the x equal to minus 3. Now value of x equal to minus 3 which is put in un, then un becomes minus 1 raised to n into minus 1 raised to n upon n. Now it becomes 1 upon n. Then our series which is 1 upon n raised to power only. Then we have to apply obviously p series, and according to the p series, given series sigma n equal to 1 to infinite 1 upon n, here p equal to 1, then we can say that given series is divergent for the x equal to minus 3. Now let's see the for the x equal to minus 1, then substituting the x equal to minus 1 in un, then un equal to minus 1 raised to n upon n. Now our series is which is in form of alternating series. If it is alternating series, then obviously one and only Leibniz test is applicable. Here summation n equal to 1 to infinite un equal to summation n equal to 1 to infinite minus 1 raised to n upon n, which is alternating series. Then mod of u of n equal to 1 upon n. Then in Leibniz test we have a two condition. Firstly, mod of u of n which is greater than mod of u n plus 1, and secondly limit n tends to infinite mod of u of n equal to 0. Let's see the first condition. Whether the checking the first condition is satisfied or not, then difference between two consecutive sequences, means mod of u of n minus mod of u of n plus 1. Substituting the values of un and un plus 1 and give the simplification, then it's become 1 upon n into n plus 1. Now substituting the n equal to 0, 1, 2, 3 and so on, then each and every values of n belongs to n, it is becomes positive value or which is greater than 0. Then we can say that each term is numerically less than its preceding term. That means mod of u of n which is greater than mod of u n n plus 1. That means given series is in form of decreasing. Now secondly, limit n tends to infinite mod of u of n, then n as a infinite, then it becomes 0. Then according to the Leibniz test, we can say that given series sigma un is convergent for the x equal to minus 1. Now let's see the basic summary of the example, means which range given series is convergent, which range it is divergent, or interval of convergence. Then here minus 3 less than x less than or equal to minus 1, given series is convergent. That means interval of convergence, that is open bracket minus 3 to close bracket minus 1. Here we also check the absolute conversion or a conditional conversion. Means in interval minus 3 to minus 1, given series is convergence. Means here we have to take the mod of u of n. Then if according to the theorem mod of u of n is convergent, then it is automatically sigma un is also convergent. Means mod of u of n convergent and sigma un is convergent. Then we can say that given series is absolutely convergent. Means this particular range minus 3 less than x less than minus 1, given series is absolutely convergent. Now here at particular point minus 3, given series is divergent, and at particular minus 1, given series is convergent. Means at particular position minus 1, given series is sigma mod of u of n is divergent, but sigma u of n is convergent. Then we can say that it is conditionally convergent for the x equal to minus 1. Now let's see the check the one more example. Find the interval of convergence of this series. Summation n equal to 0 to infinite x raised to n upon n factorial. Here un equal to x raised to n upon n factorial. Replace n as a n plus 1, means x raised to n plus 1 upon n plus 1 factorial. Here we don't know what is the exactly value of x. Then according to the root test, x which is any constant value, may be positive, may be negative, then constant raised to n, or in terms of factorial form, then obviously we have to apply ratio test. Then here limit tends to infinite, mod of un plus 1 upon un. Here we have to taken the modulus because ratio test is applicable for the series of positive term. Substituting the values of un and un plus 1 and give the simplification, then it becomes n factorial upon n plus 1 into n factorial into x, n factorial which is cancel out. Then it becomes mod x limit tends to infinite 1 upon n plus 1. Here n as infinite, then 1 upon infinite, that is 0, then 0 into anything 0, means our answer that is 0 which is less than 1. That means we can say that each and every values of x given series is convergent, means for all values of x given series is convergent. Then we have the three conditions of the ROC. Here first condition which is applicable of for the all the values of x given series is convergence, and radius of convergence that is infinite. Clear? This is all about the topics radius of convergence and interval of convergence. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this topic, then feel free contact me. Thank you so much for watching me.